What if we could write idiomatic Go and build it and run it in the browser, just like any other Go program? Can we do that? Let's find out. So today we're going to learn what WebAssembly is, how to use WebAssembly with Go, show what's possible today, and briefly look at what will be possible tomorrow. So let's start with WebAssembly. What is WebAssembly? It's a web standard assembly format. It has had cross-browser support since early 2018. It was originally built for fast numerical calculations where JavaScript would get slow. It has a JavaScript interface to access existing browser APIs and perform DOM manipulation. It could eventually replace JavaScript altogether, and wouldn't that be great? So what does this have to do with Go? So let's take a small detour first. Go4JS is a project that has allowed Go in the browser since early 2015. It's a tool built for compiling Go to JavaScript. It was written by a guy called Richard Musial. It supports most of the standard library, and there are many community bindings for existing web technologies such as WebSockets, local storage, and others. And it's very easy to use. You install Go4JS, and then you just use the Go4JS command line just like you would the Go command line. You compile a main package, and it spits out the main.js, and you can load that in your HTML file. So can we use Go with WebAssembly instead? Yes. So Go 1.11 shipped with experimental support for WebAssembly. Experimental support means that it doesn't have the same backwards compatibility guarantees as other parts of the standard library. So you can expect your code to not necessarily compile cleanly when you upgrade your versions. It was also implemented by Richard Musial. That was funny because there was like an open issue about implementing WebAssembly, started by Brad Fitzpatrick, and there was lots of discussion about how to do this. And then one day, Richard Musial popped up and said, "I've started implementing this." And everyone was like, "Yes, finally." So it supports most of the standard library, including NetHTTP client requests, which we're going to see a little bit more about later. The current implementation is focused primarily on running in the browser. And as we'll see, another consequence is that it produces quite large files. And that's partly because WebAssembly is still very early in its development, partly because of the heavy Go runtime and difficulties of implementing dead code elimination in the face of runtime reflection. This is huge numbers of blogs have been written on this subject. Essentially, it's a complicated problem. But so, if you contrast that to the Go4JS compile instruction that we just looked at, it's now built into the Go runtime, the Go compiler, I mean, and you just set the Go OS to JS, the Go Arch to WASM, and you run Go build. It spits out the WASM file, and we'll see shortly just how you use that. But we're also going to take a quick look at another Go compiler project that supports WebAssembly. You may or may not have heard of TinyGo before. It was created by Eike van Latem, primarily for using Go on microcontrollers. And it turns out that when you try to create a compiler that compiles Go for microcontrollers, you also end up trying to solve the same problems that you would want to solve in a web environment. So TinyGo produces tiny binaries. It's built on the LLVM stack. And some guy came along and opened an issue on the TinyGo repository and said, "Hey, could we use WebAssembly for this?" And Eike was like, "Yes." And so he kind of implemented the stuff for it, and someone made a Hello World example, and it turned out to be like tons smaller than the standard library implementation. And this is not a criticism of the standard library implementation, because TinyGo does not even have a garbage collector at this point. It's like a very early stages, super interesting project, a completely different direction from the main compiler. But very exciting to keep an eye on. We're going to see some examples of that later on. So enough talk about that. How do we use WebAssembly with Go? So the first thing you'll need to do is copy the necessary files from the Go root directory. In order to execute WebAssembly, you will need to have some JavaScript shims, and in this case, a minimal HTML file that kind of loads the WebAssembly into the browser and executes, or it actually just puts a button on there that you can run your WebAssembly with. So you also need to make sure that you set the correct content type. I've included a small snippet here of just a HTTP handler that kind of intercepts any WASM files and sets the content type, because no browser is going to load the WASM file correctly unless the content type is set in the response. So enough theory, let's take it for a spin, and I've got a couple of examples we're going to take a look at here. Let's see. Okay. So this is a checkout of a repository that I've created called WASM Experiments. You'll find a link to the GitHub repository in a later slide. But for now, let's just take a look at the first file I want to show you here. So we've got a hello world example, simple kind of just import Femet print hello world. And you'll notice that this includes a JS WASM build tag. Now this is just here to ensure that we only ever build this when we're specifying the correct environment variables. You don't need to include this, but it's just kind of sanity. And so let's run make hello. And so as you can see, this runs the go build command that we talked about before. It sets the correct environment variables and spits it out into the HTML directory. It also copies the files from the Go root, depending on your current Go binary, so this is kind of forwards compatible. A thing to note is that you need to make sure that you are running the same wasm exec.js as the version of Go that you're using to build your WebAssembly file. This is very important. And if you run something like this, you'll ensure that always happens. So this has been spit out into the HTML directory. And then what we've got is a little Go file that just serves the main.go. So that's serving on localhost. Let's take a look at, and I want to open the network tab here so you can see just the size of the WebAssembly file when we're loading it. So the file that we've generated here is 2.44 megabytes. And if you haven't used WebAssembly before, you'll be like, whoa, that's huge, what the hell is going on? But as I said, it's a complicated issue, essentially. And small improvements have already been made to the standard library to shrink that size a little bit, but we'll talk a little bit more later about what could possibly be done to reduce that. But anyway, now that we're here, we've loaded it, let's press run, and we get hello world. First demo, right? Okay, that's not that interesting. Let's take a look at something a little bit more interesting. So, actually, sorry, let's go back for a second. That was 2.44 megabytes. Now, I mentioned that TinyGo comes, wow. TinyGo produces tiny binaries by comparison. So let's try and compile this with TinyGo. So the make file I have here pulls the Docker container to use TinyGo and basically does all the same thing. TinyGo has its own wasm exec.js that you must make sure to use. We're using the same wasm exec.html otherwise. And if we serve that up, and let's take a look at the network tab again, when we reload the page. We've now got a WASM file that is 62 kilobytes large, and that is, I think, probably acceptable for most consumers. And, sorry, let's switch to the console first. If we run that again, it produces hello world. So this is great. TinyGo is very exciting. Unfortunately, none of the other examples that I'm going to show you today really work in TinyGo because it still has a lot of ground to cover. And also, at the same time, obviously, the standard library is going to go in the other direction. So you can kind of pick and choose TinyGo or the standard library, and you'll probably want to choose the standard library most of the time. But anyway, let's move on to the next example. I mentioned earlier that there's a JavaScript interface for working with JavaScript values and the document object module in WebAssembly, and it's accessed through this import syscall/js. And what you do essentially is you'll get a handle on the document. Now, if you're a JavaScript developer, you look at this and be like, wow, this is totally bastardized JavaScript inside Go. And it's true, but what this allows us to do is have this JavaScript interface, which allows us to do things like create element and get element, and then wrap them in kind of type-safe Go wrappers. This kind of thing already happened for Go4JS back in the day, and indeed, the Go4JS packages are almost immediately transferable to WebAssembly. So there's already a huge amount of stuff that works just out of the box in WebAssembly. For example, DOM manipulation. But I wanted to show you what it looks like. So what this does here is it looks up a div, or it looks up an element by name target. It will create a new div, set the text of the div, and then append the new div to the target. And in order to do that, we will, let's see, make JS. We will insert a little sed here at the end of our build, which inserts a target div just underneath the run button. So that is what we will attach to. Okay, let's reload the page. Let's press run, and hello world. Excellent. We've got some JavaScript DOM manipulation right inside our WebAssembly file. Okay, again, kind of basic, not that interesting. Now, I mentioned before that we can work directly with HTTP client requests inside WebAssembly. And the way that this works is, if you're interested in the kind of deeper details, the HTTP client, no, the HTTP transport, default transport, implements a fetch API-based transport to automatically translate the net HTTP client requests to fetch API calls in the browser. And all you have to do as a user is use Go HTTP client as normal. So indeed, this, if you looked at it, looks just like normal Go code. You could write this in a command line app. Just making a request, a post request to http.org, sending some content, reading it back out, and printing it. And to make things a little bit more interesting, what I've implemented just above here is a I/O writer that writes to divs inside the document. So we're going to see the output of this, not in the console, but right on the web page. So let's make fetch. And this looks exactly the same. We've got a target div, just so that we can hook onto something where we're adding the child nodes. And let's load that up. And so what this is going to do is just send a web request. We're going to get the response and just print the response verbatim to the screen. Okay, so exciting, right? This is, you saw what it looked like, right? It was pure Go, just using the HTTP new request client, and we've got the JSON response back from the HTTP bin. Very cool. So let's dig a little bit deeper and see just how far this rabbit hole goes. What I've got here is a separate repository which forked the gRPC Go library and implemented a custom transport in gRPC Web on top of the existing WebAssembly HTTP client. So this backend here, what we're looking at is just a vanilla gRPC server implementation. It implements two methods, getUser, which is a unary method which can return error, and getUsers, which is a stream. And the front end, if we look at this, it's got some Go generate stuff to do the copying of WASM exec and the inserting of the target div and all of that, the stuff that we had in the make file before. It's got our nice I/O writer that prints to a div, but otherwise this looks just like a gRPC client. And you dialed nothing because you're just connecting to yourself, the local host, and otherwise everything below that line essentially looks exactly like what you would expect a normal gRPC client to look like. So we've got a new backend client. We're doing some requests here. Skim over the details. Essentially, the first one is going to succeed, the second one is going to fail. I want to print the error here. And then what we've got is a stream. And streaming is always exciting. So let's see if this works. So this runs proto-C, runs GoGenerate on the front end, which copies all the files, outputs it to a HTML directory. We run Dmitry Shiralyov's excellent asset generate thing to compile the static assets into a Go file, and then we run go run main.go. And so I think you might be curious just how large this is. So this is a 15.6 megabyte large file, but that's okay because we're totally compiling the entire gRPC server stack, including the HTTP stack, into the binary. So don't worry about it. Everything is A-okay. So you saw the client. What it does is it will call, first make a unary call, which will succeed. Secondly, it will make a unary call which should fail, and then it should make a server streaming call that we should see kind of slowly print onto the screen. Ta-da! Okay, thank you. And those were the examples. So let's take a step back and look at what the future of WebAssembly will look like. Obviously, WebAssembly is only, what did I say, early 2018. We're just on version 1. Things that have already landed in the spec, things that are planned to be implemented in all browsers is threading. I think the Chrome beta channel already supports threading in WebAssembly. Go doesn't support it yet, as far as I know. But we can look forward to things like the auto-generated DOM bindings from the WebIDL spec for the DOM. Go WASM frameworks. Vecti is a popular framework for Go for JS. It already runs with WebAssembly, produces huge files. Native browser APIs, so you don't have to go through the JavaScript bridge that I showed you in order to manipulate the DOM. Threading and garbage collection. Garbage collection could be one of those things where, okay, Go doesn't need to compile in the garbage collector anymore when it's running in WebAssembly mode. Maybe that could help reduce file size. Just continual improvements to the WebAssembly spec and implementations. And maybe most excitingly of all, something I haven't really touched upon here is that WebAssembly could technically run anywhere where you have like a WebAssembly interpreter. And people are writing things like WebAssembly interpreters for running on ARM or running in the cloud. It could be better than, like Java, but better than Java, you know? So except for, you know, replacing JavaScript, we might also end up replacing Java, which would be great. Okay, so I mentioned I would include some links here. The links to my WASM experiments repository, the gRPC Web WASM example, some information about WebAssembly, and there's a fourth link there is a blog to the future WebAssembly. I encourage you to join the WebAssembly Slack on Go for Slack and the TinyGo channels as well. And so, can we run Go in the browser? Yes, but not without caveats yet. But the future is very exciting. I hope you will join me. Thank you.